This lesson is a lesson on gas stoichiometry. Starting with the definition of 1 mole of any gas at STP, standard temperature and pressure, 1 atmosphere, 273 Kelvin. 1 mole of any gas at STP has a volume equal to 22.4 liters. Since most of the gas is empty space, the size of the gas doesn't make any difference. So the size of the particles doesn't matter, it's just the number of particles that matters. So any gas at STP volume is equal to 22.4. So your conversion factor would be 1 mole over 22.4 or 22.4 over 1 mole. So if you do that, do a sample stoichiometry problem, 2H2 plus O2 yields 2H2O. If you had 11.5 liters of H2, how many grams or what mass of O2 would you also need? So 3-step problem, 11.4 liters of H2, 3 bars, 1 mole on top of the first, 1 mole on the bottom of the second. Since it's liters, you gotta have 22.4 here. We're looking for O2, so that's 1 O2 and 2 H2, and the grams of O2 is 32 grams. So you do that, that's 1/4, so 16/8. So the mass would be 8 grams of O2. The H2's cancel, liters cancel, and the moles cancel. If you were to ask for liters, you'd have 22.4 liters there. Suppose you did an experiment and you ended up with, say, 7.3 liters of some gas. That is at STP. If you're not at STP, then you got to do PV over T equals PV over T. The first pressure that we know is 1 atmosphere. The volume we know is 7.3 liters because we did our experiment, our stoichiometry came up with that, over 273. But now we do a lab, and it's not at STP. We are comfortable at 20 degrees Celsius in the lab, and since we're not sea level, our pressure, our atmospheric pressure is 0.9 atm. So we have to adjust for that. Instead of 1 atm, we have 0.9 atm. The volume is what we're trying to find. And then add 20 to 273, you get 293. Cross multiply and solve, and you'll find your volume of your gas. That ends this lesson on gas stoichiometry.